7/8 plus 3/5. Do I need a common denominator? Yes. Can I use 8 or 5? No. Multiples or multiply? I choose multiply. 8 times 5 is 40. Because the bottom number changed, the top number must change as well. How many times does 8 go into 40? 5 times, obviously, since you multiplied 8 times 5 to get 40. So your giant one is 5 over 5. 7 times 5 is 35. How many times does 5 go into 40? 5 goes into 40, obviously, 8 times, because you multiplied 8 times 5 to get 40. So your giant one is 8 over 8. 5 times 8 is 40. 3 times 8 is 24. 35 plus 24 is 59/40. 59/40 is an improper fraction. Take out one whole. 40 pieces make a whole, which leaves 19/40. 1 and 19/40. Which brings us to our next problem. 2/3 plus 4/7. 2/3 plus 4/7. Do I need a common denominator? Yes. Can I use one of these? No. Multiples or multiply. 3 times 7 is 21. 7 times 3, 21. How many times does 3 go into 21? Well, we just multiplied by 7 to get 21, so my giant one is 7 over 7. 7 times 2 is 14. How many times does 7 go into 21? We just multiplied by 3, so it's 3 over 3. 4 times 3 is 12. 14 plus 12 is 26/21. Again, we got to reduce. How many pieces make a whole? 21. How many are left over? 5/21. Next problem. Mixed numbers. With all mixed numbers, the easiest way to solve them, whether adding or subtracting, will be to turn it to an improper fraction. How many pieces make a whole here? 3. How many wholes do I have? 2. 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7/3. How many pieces make a whole here? 5. How many wholes do I have? 3. 3 times 5 is 15, plus 2, 17. And now I have a problem. I've converted them to improper fractions, but I still don't have a common denominator. So I need a common denominator for 3 and 5. Multiples or multiply. 3 times 5 is 15. 5 times 3 is 15. My giant one. 5 goes into 15 3 times. 3 over 3. 3 times 17 is 51. 3 goes into 5 times. My giant one is 5 over 5. 5 times 3 is 35. 35 plus 51 is 86/15. Whole bunch of wholes. 15, 15, 30, 45, 60, 75. There are 5 wholes to take out. And then they are what left over? 11/15. Which brings us to the next problem. 1 3/4, 2 1/3. And the key here is to turn it into an improper fraction first. 4 pieces make a whole. You have 1 whole. 1 times 4 is 4, plus 3 is 7. 4s plus 3 pieces make a whole. 2 wholes. 2 times 3 is 6, plus 1, 7/3. But before I can continue, I need a common denominator. 4 times 3 is 12. 3 times 4 is 12. 4 goes into 12 3 times. My giant one is 3 over 3. 3 times 7 is 21. 3 goes into 12 4 times. My giant one is 4 over 4. 7 times 4 is 28. 21 plus 28 is 49 twelfths. How many groups of 12 go into 49? 12, 24, 36, 48. How many was that? 4. And how many are left over? 1/12. Next problem. 2/3 of 5/6. Which one do I put across the top? The one with the biggest denominator. 5/6, which means I need 6 columns. How many of them are shaded? 5 of them are shaded. And then I put the other fraction on the other side, 2/3. How many rows do I need? Look at the denominator. I need 3 rows. How many of those are shaded? 2, 1, 2, and I am interested in only the double shaded or the intersection. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 18. 18. We can rewrite this problem 2/3 times 5/6 because of means times. Multiply across the top. 2 times 5 is 10. 3 times 6 is 18. Do they match? Yes, they do. Can they be reduced? Yes, they can. 10 and 18 are both divisible by 2. 10 divided by 2 is 5. 18 divided by 2 is 9. Which brings us down to how to multiply mixed fractions. Mixed fractions need to be multiplied by first converting them to an improper fraction. How many parts make up a whole? 3. I have 2 wholes. 2 times 3 is 6, plus 1 is 7, times. How many parts make up a whole? 5. 3 wholes. 3 times 5 is 15, plus 2 is 17. 7 times 17. 7 times 17. 119 over 3 times 5, 15. Are there a bunch of holes that can be taken out of there? 15, 30, 45, 60, 75, 90, 105. How many is that? 7. And 14/15. 5.5 times 3 and 2 and 1/3. I'm going to skip that because you guys can do that on your own. 2 times 3, 3 plus 2 times 4 is
11.
20. No. Hemdas. Gemma. Gemdas. Multiplication comes first. 2 times 4 is 8. 3 plus 8 is 11. And now comes the part that's going to help you with your homework. And your homework is page 9 and 10 of your integer packet. So this you definitely need to take notes on now. So here we go. 3 times 2 equals, on a line model, 3 groups of 2, 1 group, 2 groups, 3 groups, and where do I end up? 6. 3 groups of 2. If the first number is positive, you're putting things on the board, and the second number tells you what to put on the board. You're putting 3 groups of positive 2. And 1, 2, 3 groups of positive 2 equals positive 6. That's pretty easy. So let's look at 3 groups of negative 2. 0, 1, 2, 3, 4, 5, 6. Negative 2, negative 2, negative 2. And what's my answer? Negative 6. 3 groups of negative 2. I'm putting 3 groups of negative 2. 1 group, 2 group, 3 groups. What's my answer? Negative 6. Those were the easy ones. The next one's going to be a little more difficult. Negative 2 times 3. And in this situation, you want to think of it this way. On a number line, you're negative 2. You're facing forward, but you're going backwards. Negative group of 3, negative group of 3. Where do I end up? Negative 6. In a chip model, it looks like this. I'm taking away 2 groups of positive 3, but I don't have anything on my board. What do I put on my board when I don't have anything to take away? These wonderful, lovely, neutral pairs. And now I'm taking away 2 groups of 3. 1, 2, 3. 1, 2, 3. Off the board they come. I'm left with negative 6. So when you take positives off the board, you're leaving behind negatives. Which brings us to the next one. 3 times negative 2. Wait, we already did that one. So let's do this one. Negative 3 times negative 2. Chip model looks like this. I'm taking away 3 groups. What am I taking away? Negative 2's. I don't have any negative 2's. What do I put on my board? Neutral pairs. That's right. You guessed it. I'm taking away 3 groups of negative 2. Negative 2, negative 2, negative 2. Boop, boop, boop. Off the board, off the board, off the board. 0, 0. What's the answer? Positive 6. So now I'm going to tell you the rules that go with this. A positive times a positive equals a positive. A negative times a negative equals a negative. A negative times a positive equals a negative times a negative equals a positive. A negative times a positive equals a negative. And a positive times a negative equals a negative. So let me explain this to you in a way that you'll understand so you can remember the rules. I wouldn't pack up right now. You definitely want me to finish this video. If the signs agree, positive, positive, your answer is positive. Negative, negative, your answer is positive. If your signs disagree, negative, positive, your answer is negative. Positive, negative, your answer is negative. So let me explain this to you in a way that you'll understand. Sammy goes to the mall with her favorite person. Sammy says, "I'm positively hungry." And her favorite person says, "I'm positively hungry." So they positively go to lunch, and they are both happy because they agree. Sammy goes again with her favorite person, and this time she says, "I'm not hungry." And her friend says, "I'm not hungry." And they are positively happy because they agree. And then, close the door. And then Sammy goes to the mall a third time. And she says, I'm not hungry. Her friend says, I am hungry. They don't agree, and they are unhappy. Negative. And then Sammy goes a fourth time. She says, I'm hungry. And her friend says, I'm not hungry. And she says,
I'm not hungry. She's not hungry.
She says, we're not happy. Let's break up. Negative. No talking. Signs agree. The answer's positive.
You're recording?
Signs disagree. The answer's negative.
You're still recording.
I wish you luck on your